Okay, the next overview presentation I have for you is to make you aware of what we call the lean payload integration process. And this is fairly new. It has been in work for probably the past year and a half or so across all of the OZ payload integration and ops teams. And so let's move on to the next slide. And someone alluded earlier to the schedule time frame of how long the integration process takes. And through our experiences, we have found that we were in a situation where a lot of payloads, we were made aware of them much closer to an anticipated launch than the templates you saw earlier today reflect. And we found we've had to work at integrating payloads in a much more expedited fashion. So we thought, well, we're working this madness. Let's try to put a method to the madness and actually define a process that can accommodate payload integration on a more expedited schedule. And we call that lean. When we set out working this, our goal was to achieve a 6-month payload integration template. Please do note that your payload development template to conduct your research remains as is. But by payload integration template, I mean, how late can we become aware of you and work all the interfaces and integration products to get you launched and your on-orbit operations and post-landing operations adequately planned? Now, why did we choose 6 months? Well, that's very responsive template, knowing that our national lab customers may have more limited funding and desire a more responsive timeline. And it does drive out payload developers having to submit multiple iterations of information over time as you're maturing your payload design. That helps you. It helps us as well because we only see the data one time and we know that it's good, valuable data to integrate into our products. There were some guidelines established for this. You'll hear more about the payload safety review process a little later today. That remains unchanged, so we couldn't do anything with the safety review process. We couldn't do anything to change agreements that are already established with the crew office regarding crew training, things along those lines. And we had to whatever we did, we had to maintain overall ISS safety and payload interface integrity. So that's what drove us as we looked at doing this. What has come out of this? Well, we have characterized a set of payload operational characteristics that I'll go over with you. And we've looked at aspects of hardware and software for express rack payloads and for microgravity sciences glove box payloads. Things about those types of payloads and characteristics that we could accommodate in a more streamlined fashion. And maybe you'll be able to fit into one of these areas. Although we have focused initially on Express and MSG, as we get familiar with this lean integration process over time, we want to expand that to research that might be hosted in other areas. So this is our starting point. And in order to accommodate all this, you'll see something that's very different, a gate process that we have defined to work with lean payloads as we carry them through the integration process. One of the primary things we have done is implemented ship and shoot testing. Kentucky Space referred to that process yesterday, and I'll give you a little more detail about that as well. Page 3, please. Okay, first of all, I'd like to focus towards the bottom part of this matrix here and overview for you operational characteristics that really will apply to any lean payload, whether it's Express or MSG. So if we go through the bottom portion of the matrix there, If your payload will not have any crew displays or required any unique skills to get it established, you can use your standard procedures for maybe your host facility. You could qualify as a lean payload. The crew interaction would be limited to setup, takedown, and some sort of sample exchange. The crew training is minimal. The ops team and the astronaut office would review your payload and agree on consensus that your training could be conducted pretty much on board through self-study crew-based training. Your payload would have to be able to fit within predefined operational characteristics, which are placed on a mission plan early on. And you could have standard ground command services from one ground command site only. So think of these as operational characteristics. If they apply to you, you might be able to fit within the lean payload box. Now, if you're an express rack payload, we have 3 different types of hardware configurations that might be applicable to this process. If we start with the E1 column, your express rack payload would be a single locker equivalent in size. It would be soft stowed with no services required during its launch or return to Earth. We would capture all of your engineering interface verification data, which Mike Miller just talked about. We would capture that via the ship and shoot testing process. And your resources would generally fall within this range, about 150 watts average power. You could be air and or water cooled within the express rack. You would have Ethernet data, transmission only, and you would not require any of the resources for gas supply or vacuum interface, which can be made available for express subrack payloads, but it would not apply to a lean payload. Your software architecture that you put in place, your health and status, commanding, telemetry, everything I just talked about, would comply with a pre-built generic CNDH data set that we have established, and we will have more information available on the specific characteristics of that. It's very generic in nature, is very well bounded to capture most of the things we have seen needed within a CNDH data set, so we can provide more information to you. Okay, so if you meet everything in column E1 and the ops characteristics, you can be a lean express payload. You'll go on a different integration track. Similarly, if we look over at E2, which would be an express payload that's a reflight. Again, your single locker equivalent. You've previously flown. Again, you're soft stowed during your launch and your return. For your verification, there's already a process in place, a fairly simple process for reflight payloads, or we could capture your interface verification data using the ship and shoot process. Up to you, we could coordinate that. Regarding your software interface, if you've flown before, we could reuse the CNDH data set that you already have placed into PDL and with no changes to your data set. That's another candidate for Lean Express. And then the column E3, you could be a small deployed payload at an express rack or in front of an express rack and get a power supply fed to you from the express rack. Here are envelope bounds of sizing considerations that would qualify you as a lean deployed express payload. And again, you would be soft stowed with no services required, and you would not have a software interface. So if you're a candidate to do your research in an express rack and you can comply with all of this, we'd like to work with you using the lean process, and I'll tell you a little bit more about that. Okay, if we go to page 4, this is a similar matrix for lean MSG payloads. Again, down at the bottom, you'll see that the flight operations characteristics are the same as they were for Express. If we look at the M1 column and look at the hardware characteristics, the MSG payload would be smaller than a locker equivalent in size. It would not require any resources to conduct its research. It would be soft-stowed during launch and return. The toxicity level would be 0, no unique hazards. The safety reviews would be conducted out of board. You'll understand that better, I guess, after the PSRP overview today. The verification for this lean MSG payload would be by certificates of compliance, and no EMI testing would be required. As far as the software for this type of lean MSG payload, no requirements for commanding or telemetry. Any data or video downlink would be limited to the normal capabilities the MSG facility provides regularly. There would be no crew displays. A very simple research going into the microgravity sciences glove box. Looking over to the right column, column M2, that could be a little bit larger in size, again soft-stowed. EMI testing could be conducted, but when you show up around 6 months prior to launch, they already want your EMI testing to be completed. You can require power if you're an M2 lean MSG payload, as long as you don't require more than 500 watts of power and cooling. Here's information about your toxicity level. Only one level of containment or less is required. The integrated safety reviews have been conducted out of board, and you will have simple verification testing, the ship and shoot testing, which I'll overview in a little bit. As far as software, your M2 lean payload can be operated from the ground. All the data transfer and commanding is done via the standard MSG laptop computer server, which is there available to you, and only the standard displays are needed to conduct your research. There's no unique crew displays. Okay, if we move on to slide 5. I've overviewed for you the types of payloads that could get on the lean integration track. Now I'm going to overview for you the gate process that we've established to assess and manage this and usher a lean payload through the integration process. Down at the lower portion of this slide, the blue blocks, you will see key things that the payload developer needs to do within the lean integration process, and the upper level are key items that the payload integration team we will be concerned about within the lean integration process. You'll notice there's not really any time frames on this chart. The only time frame is as late as 7 months prior to launch you could be manifested. So everything, Gate 1, Gate 2, and Gate 3, the time frame can be conducted as appropriate with your payload development cycle. Okay? So let's look at Gate 1. This would be when you initially contact NASA regarding your payload, and it'd be very good to provide the 2-pager information that Rod Lofton showed you earlier. Give us some very initial information about your lean payload. NASA becomes aware of it. A strategic PIM will start looking at that overview information and contacting you. And what the PIM will do, if the PIM thinks you are a candidate to be a lean payload, is he'll call a review meeting together with key people noted down there at the bottom of the slide. The host facility lead, if you're going to be integrated into a host facility, a representative from the engineering integration office, software integration, operations, point of contact from the payload safety review panel, and a crew office rep. They will meet with you early on, probably ask you some more questions, and if you meet the characteristics I went over on the previous 2 slides, we're going to say, okay, we're going to integrate you as a lean payload. and put you on that integration track. You still will establish a program agreement, PIA, and have to get your export compliance conducted, but you'll be put on the lean integration track. Okay, so let's move over to Gate 2. You'll notice down in the payload developer world, you're still developing your payload. And the blue block above that with items you need to complete, we call that early work that we require from you. We tried not to require any work prior to you coming to us about 7 months prior to launch, but these are things that require some amount of time and your best to try to get this early work conducted. So these are things you would still need to do early on, even if you're in the lean process. You're still marching through with your payload safety reviews as required. You have heard reference to the operations nomenclature, OPNOM. That's the official name of your payload and information about your hardware. You really want to go ahead and get into that request cycle of getting all of that ironed out. As you are going through your payload design, you still want to have preliminary help from the HFIT and IPLAT organizations, which Mike Miller alluded to, your human factors and about the labeling, your planning for your equipment. They can look at your design early on, help you correct things if they're not in line. Early on, you're going to have a ops assessment review as well, and meet with representatives that are called together for an ops training strategy team. Carmen Price will tell you a little bit more about that this afternoon. And again, as I mentioned in the previous presentation, if you're going to be operating from a new site, ground site remotely, you want to go ahead and start working with the integration team to get that put in place. So a very minimal set of early work while you're completing your payload development. So when you do complete that early work, you want to let your PIM know. You want to stay in contact with your PIM, and your PIM can answer you questions. At the end of Gate 2, we're going to look at this early work, make sure everything's on track. If something has changed between Gate 1 and Gate 2 about your payload, your hardware, or your software, we still want to keep you on your lean track. We might have to, at the end of Gate 2, assign some additional information you're going to have to get to us so that we can keep you on the lean track. All righty, so hopefully you're still in the box. We move on to Gate 3, where really you are completing your payload development, completing your Phase 3 payload safety data package, and you're developing the lean integration data package. And we'll go into more detail on that the following page. Again, it's an attempt at a minimal set of integration data you need to feed into the program, and we take that and work that to get you manifested and operated. So you and your PIM will get your information to us, and we will hold a review then at the end of Gate 3, looking through all your lean integration data package input, making sure everything's complete. And we will, at that point, that review team will target candidate launches, could be roughly 7 months, from that point in time. And the change evaluation form that George talked about earlier will be submitted to officially get you manifested onto a flight. Okay? That can occur as late as 7 months prior to a launch. So, yay, you're manifested for flight. Then what happens? Gate 4 is pretty much can be 6 months prior to your launch, where you're going to be providing final input to ops products. You'll learn more about that this afternoon. Your hardware needs to be available for the ship and shoot testing. We'll talk a little bit more about that. And as a PD, you're going to support that required testing and help us feed in appropriate information about your certification of flight readiness as we're coming out of your testing. Our integration team will be conducting ship and shoot testing with you. we're going to be completing the standard integration things that we deliver on our side of the house, and the ops community will be finalizing all of the operations product development. Okay, let's move on to the next slide. This is a chart which lists everything you submit at the end of Gate 3 as part of your lean integration data package. There is technical data that we'll request from you. For express subrack payloads, we have a new tool called the Lean Integration Data Sheet, asking you information about your resource uses. The MSG host facility has an interface requirement sheet that you will complete and submit at that time. And that's used by the engineering community to develop your ICD and to tailor generic ship and shoot tests for the specific interface resources your payload has. As far as hardware, in your lean integration data package, you submit your on-orbit drawings. You're going to submit information about your hardware, physical characteristics so that we can put it into the system, get it into the payload tactical plan, which George talked about previously, so we can keep track of your manifest and return requirements. Your coal stowage data, additionally, will go into the system. You provide us information about that, as well as if you have any waste, any elements that can be disposed of after your research is complete. You'll provide that input to the program. Let's see, key environmental tests such as off-gas testing, vibration, acoustics, EMI, and EMC. You can have those things conducted prior to Gate 3, and that's probably a good idea. But if not, well, if you do have them done prior to Gate 3, go ahead and turn in those results. And if not, I think Annette Sled will be talking with you this afternoon about some capabilities at Marshall. There's capabilities at other centers also for hosting this environmental testing. But if you have any test results from those environmental tests prior to Gate 3, turn those results in so the engineering community can start taking a look at it. As far as payload operations, we're going to need your training material turned in at Gate 3. And remember, these are payloads where training can be conducted on board. So you would want to have a cut at your ground-based crew training material. Turn that in. At that point in time also, you'll turn in preliminary information about your mission planning, you know, how much crew time you need, what type of resources, your resource levels and durations, so that the mission plan can start to be refined. And you're going to turn in your preliminary crew and ground command procedures for the integration team to pick those up and continue refining those. Regarding payload safety, you should have your Phase 3 safety data package turned in for review at that point in time, and also a ground safety checklist, which is going to flow with your lean payload as you work through ship and shoot processing through your bench review and it arrives at the launch destination. Okay, next slide. Now I'm going to tell you a little bit more about ship and shoot testing. And the purpose of ship and shoot testing is to get your payload and verify the interfaces your payload has with Express or MSG within the ship and shoot processing. You're not having to submit a bunch of individual verification closure items to be reviewed by the engineering community. The benefits of this are it provides a lot of efficiencies for ship and shoot processing to conduct that verification. We can also get your crew procedure review performed during the ship and shoot processing time frame. We can also get a final look at your human factors considerations and your labeling for final review, all within a single activity. We'll bring everybody together to ship and shoot process your payload. As I mentioned, it does eliminate the verification submittals that you as a payload developer have to provide into the engineering integration organization, reducing your overall cost and time to generate that information. It does, on our side of the house as well, reduce the PEI workload for tracking and evaluating each individual verification data package. And it does support crew procedure validation with the hardware, as I mentioned. Okay, moving on to page 8. This is a general high-level flow of the ship and shoot testing process. We are developing a ship and shoot processing guidebook to have available to you, so if you're a candidate for this, you'll understand how ship and shoot processing is conducted. First of all, your lean payload will arrive at Marshall and will be handed over for ship and shoot testing. There's some pre-integration tests that we're going to do to characterize your power characteristics before we actually integrate you with the Express Rack Flight Equivalent Unit or the MSG ground unit. We will conduct a test readiness review going over all of the technical data you've submitted to the program and your overall ship and shoot test plan. We'll integrate you with the Express or MSG test setup, collect your data, execute our test, collect your data, and also conduct a crew procedure review if there's interactions with your hardware and software at that point in time. If you're an Express water-cooled payload, then when the ship and shoot data collection is all complete, you'll be processed to have your fluids discharged and injected properly for the launch environment. They will do a final verification of your human factors requirements at that point in time, and you'll be pre-packaged into your CTBs, not your cargo transfer bags. You'll be pre-packaged into your bags, which will then go into CTBs after you arrive at JSC and the bench review is performed on your hardware. We expect this typical flow to be about an 8-day process, 8 to 10-day process overall. Your payload hardware will not be returned back to you after ship and shoot testing. Coming out of Block 5, 1.5, your ship and shoot data collection, it's not shown here, but the engineering data will be reviewed by cross-functional teams to make sure all the data collected meets the ranges that we expected at the payload interface, and hopefully all of that goes smoothly. And let's see, look at note 3 there. It says your off-gas, vibe, acoustics, EMI or EMC testing may be conducted at Marshall at the PD expense. The PD should coordinate with their PIM as early as possible. And again, you could get those environmental tests conducted prior to entering ship and shoot testing flow at Marshall, or you can have them conducted earlier elsewhere. Okay, next slide. I believe this is my final chart, and please keep it as a reference. It'll mean more to you after Carmen Price's discussion this afternoon. But it pulls together all the operational aspects for a lean payload and reminds you again, during Gate 2, there's a good bit of early work, all related to ops integration that needs to be conducted. At Gate 3, as part of your lean integration data package, again, more ops integration work is requested of you. And then as far as the green taskbars, the ops integration community pretty much takes your input and does their standard things they do at that point in time, which would be roughly 6 months prior to your launch and hopefully start of your on-orbit operations. Next slide. I was right. That was my last one. Okay, questions on this?
I've got a couple questions about this ship and shoot testing that you talked about there.
Mm-hmm.
It looks a lot like PRCU testing that was conducted previously at the Cape.
Mm-hmm.
But there's some components missing. For example, do you do end-to-end data testing as
Yes.
a part of that ship and shoot?
Yes.
Okay. So it really is just moving PRCU testing to Marshall, which gives you then the ability to conduct some of these other tests with
In
other
conjunction.
facilities that are there.
Correct.
One question I have then, well, one last question. Most of the people here are talking about biological-based payloads. A concern I would have is the statement that you hand over your hardware at the end of this testing and that it goes directly to bench review and you don't see it again. So I'm wondering, are you contemplating some kind of a hybrid process, because biology can't go months
Yes.
beforehand in most cases and get wrapped up like that. So some component of the payload is going to have to come late.
Exactly. If you have late load items, things that need to be environmentally controlled, I think we would handle those items per the standard process.
But so it might be possible to still use this lean process even though you don't really fit that
You could
component
use
of
it for your hardware itself, if you have new hardware going, but as far as your biological component, which is time critically controlled, you could send that up additionally, in the freezers, work with cold stowage, or work with we could process that through a late load requirement.
Okay, thank you.
So I think we would work that.
Do any of the soft storage requirements change depending upon the vehicle you're going up on?
I don't believe so. I believe OC has developed a standard set of carrier requirements, regardless of your transportation vehicle. We could certainly get you that requirements document to make sure. I don't know. Can anybody help me answer that from OZ?
Yes, we have a requirement set based on the common interface requirements document the vehicle uses. It envelopes all of the different launch vehicles, and so we would just invoke that set of requirements.
But as far as soft stowage, do you know offhand if there's any differences on the vehicle?
The different vehicles do have different loads. Typically, for payloads, because it's not critical, for crew or mission, the payloads can choose to take the risk in the soft stow if they're not safety critical structures. If they're safety critical structures, then they have to analyze to the loads, and there's things like pressure bottles, glass, things like that, or if they're hard mounted, during launch, obviously, a powered mid-deck would be safety critical structure.
Yeah.
But the other items, they could say, I'm in foam, I'm willing to accept the risk.
But you give those loads to the developers so they know whether to take that risk or not?
Yes, we would have that set of requirements referenced in your payload unique ICD. And the common IRD has the envelope of loads, and then it also has in the appendixes the unique loads, just for reference if you know exactly what vehicle you're going on.
Mike, I had a question. Are you guys developing something like what OB developed? It's a common IRD where they have a common set of storage requirements for multiple vehicles?
Yeah, rather than developing something new, we just reference that data and then we tailor it for payloads. So instead of something that might need a vehicle process, we would point to the payload process.
Thank you, Mike. Any other questions?